Hello, everyone. My name is Eric Abbott. I'm a technical support manager for Lalemon Brewing, and thank you all for being here. And welcome to this Lalemon Brewing webinar, Lager Brewing Tips, Improve Your Process with Enzymes and Process Aids. Lager, especially light lager styles, are difficult to master. Their delicate flavor profile means that off flavors have nowhere to hide, and flavor consistency is more of a challenge. Lagers are also a high volume beer style, so any solution that increases efficiency or yields has a much greater impact. Lager brewers are already familiar with step mashing, fermentation control, and cold maturation. In this webinar, we'll teach you how to further optimize your lager brewing process. I'm joined today by Sarah Young, Product Manager for AB Vickers, who will discuss how nutrients, enzymes, and process aids can increase efficiency, boost yields, and improve product flavor and stability. Sarah studied brewing and distilling at Heriot-Watt University in Edinburgh before working at small and regional breweries in the UK. She has worked for AB Vickers since 2002, where she now holds the position of Global Product Manager for Process Aids. Nate Armbrust will then discuss filtration considerations that are specific to brewing lager styles. Nate has a bachelor's in food science from Oregon State and more than 25 years' experience in the beverage industry. Currently, he is based in Oregon, where he works as a beverage integrity and filtration specialist with Scott Labs. We'll give Sarah about 30 minutes for enzymes and process aids, and 15 minutes for Nate for filtration, followed by about 15 minutes for questions at the end. There is a question tab at the right side of your screen, so please put your questions there and upvote any questions that you want our experts to answer. This webinar is recorded and can be accessed from the original Crowdcast link, where you will also find written answers to any questions we might not have time for. The video will also be posted on our YouTube page as well. With that, let's get started with Sarah Young. Take it away, Sarah.
Okay, can everyone see my screen? All good?
All good, Sarah.
Oh, lovely. Okay, welcome. Thank you for joining us with the Lalemon Brewing webinar on lager brewing. I'm glad you can join us. So here is a quick run through the topics we're going to cover in the next 30 minutes. Process aids are really quite a large area. So if anybody has any specific questions, please feel free to reach out to me after the presentation because, like I said, it's a very, very large area to discuss. Okay, so let's run back a little bit of background. So let's set the scene. So the first records of beer being lagered or stalled cold was about the 15th century in the Bavarian area. And these cold or cooler fermentations led to the discovery that beer tasted better when it was brewed and stored in the cooler months. And then a law was brought forward dictating that the brewing season was only going to be between the months of September and April. Beer at this time would have been very dark and smoky due to the direct roasting of the malt. And the pilsner style didn't really come to the market until the mid-1800s. And then really since then, pilsner had become the benchmark of all modern lagers and Helles as well now. So lager, as we know today, is having a resurgence in the popularity in the craft sector. However, the delicate taste requires a balance of ingredients, and off flavors cannot be hidden behind high hop additions. And Pilsner and Helles are the least forgiving of any style of beer. So historically, lagers were made using poorer malt, high protein levels, under modification, and this malt would be completely unsuitable for what we use as an infusion mashing in the UK, which is like one temperature mashing. And these high protein levels and smaller, less accessible starch granules meant that you needed to start with a lower temperature to allow more protein breakdown. And then taking like the decoction mashing, taking the mash out, boiling it, really helped break down the starch granules, burst them, gelatinize them more thoroughly. And then the cell walls of the endosperm were destroyed more effectively. So lager malts now and ale malts differed significantly in the past. Again, like I've just said, the lager malts really having these higher protein, high nitrogen levels, high beta-glucan levels. And now, realistically, extra pale ale can be badged as a lager malt. Really, it's only the beta-glucan spec which can be wider. And lower levels under 100 mg per litre, beta-glucans shouldn't really cause you a problem. But when you're north of this and you're kind of in the realms of like 150, 170, your lautering will become affected. And also, generally, like I said, these wider specs for the beta-glucans for lager brewing can be a little bit tricky, because you do get a lot of variation sometimes. So it's generally the beta-glucans that do cause you a bit more of a problem these days. Going forward with global warming, lots of warmer weather, higher temperatures, and when you combine these with a low rainfall, you'll be increasing levels of beta-glucans, you'll be increasing protein levels, and also gelatinization temperatures, which are going to impact on extract clarity and filterability in the future. So let's talk about process aids for lager brewing. Now we have a nice schematic of the brewing system. So mashing, here we're looking at oxidation and enzymes. I think this is the only slide that does that fancy bit, just to let you know. So let's start with mashing. We did this before. Right, let's start with mashing. Those light cream crisp flavors need to be protected right at the start of the process. Lower mashing temperatures increase LOX activity, and this is the activity of lipoxygenase enzymes, namely LOX1 and LOX2. So LOX2 is a bit more temperature labile, so it's generally LOX1 that's a troublemaker, and these can increase the elevated levels of trans-2-nonenal, or this is the cardboard flavor, which develops in beer once it's packaged. So if you are doing a stout mash or decoction mash or lower temperatures, it's really worthwhile to use and mash antioxidants, such as we have one called Viscount SPX, which is a blend of antioxidants and tannic acid, which scavenges the oxygen, but also the tannic acid will chelate the metal ions, preventing the formation of the reactive oxygen species further downstream. Moving on to enzymes, with the increased use of adjuncts such as rice and maize and barley brewing, if the adjuncts are not pre-gelatinized, they can require higher addition of a high temperature alpha amylase to break down and liquefy the starch. And then amyloglucosidase, this is an enzyme which increases the attenuation of beer for a drier finish. It basically breaks glucose down off that starch chain. If you're adding the AMG into the mash, it allows you more control over the release of glucose, which the enzyme is then denatured in the boil, so therefore is no risk for the downstream. If you're adding IMG into the fermenter, you must make sure that you're reaching that terminal gravity, because if not, if you're packaging with the enzyme present and there's yeast there, you can have re-fermentation. If you have filtered the beer, as you would probably do with lager, brighter beer, it can sweeten because the AMG will keep on breaking those glucose molecules off. And then, as I talked about earlier, regarding the beta-glucanase really does increase the throughput of your brew house. Especially if you're using wheat to increase your head potential, you really could do with using beta-glucanase that really has some side activity, some organoxylans, which will really aid the filtration, the mash filtration of your beer. Obviously, any beta-glucanase that you add in the brew house, breaking down as beta-glucans, will impact on beer quality and improve filterability further downstream. I have got another graph here for you. So this is a lagering graph for beta-glucanase. We've got 3 different mashes here. The first mash, the blue line, this is the control with no beta-glucanase. And then you have 2 other mashes that do have beta-glucanase involved, the orange line and the grey line. And as you can see, using different beta-glucanases really does impact on the work filtration, but also it does impact on the gravity as well. So when you're speaking to your rep regarding your enzymes, tell them about what you're wanting to produce, what kind of style of lager you're producing, are you using wheat, what adjuncts are you using, and they will come with the best enzyme for you to use for your application. Moving on to protein removal and carrageenan. So this is a rather simplistic slide regarding protein, because malt proteins really overlap into both sides. But what I'm trying to illustrate is that proteins have got positive roles in the formation of foam and as a source of amino acids, but increased quantities do lead to haze and increased solids loading, which will impact negatively on the quality of the beer in package, and also on the throughput of the beer through the filter, which will impact on your efficiency. In low protein years, lower mashing temperatures with modified malts can impact negatively again on your foam potential. So again, it's both sides. If you do have a low nitrogen level, you can, and you're using lower temperature mashing, you can really impact on your foam proteins. And then if you're using a very broad spectrum protease, again here you're doing you can really impact again on your foam stability, because it will ruin foam if you're using a broad spectrum protease. But realistically, you do want to remove a portion of the protein in the wort, ideally upstream because it's the easiest place to do it. And this is the first step, really improving your beer clarity, the stabilization, and the filterability of your beer. So how are we going to do this? Carrageenan. Carrageenan must be one of the most used process aids. Chondrus crispus, or Irish moss, was the first one available, really. And now we use a species called Euchymcotonii. This is higher in a kappa isomer. So carrageenan has 3 isomers. You've got kappa, lambda, and iota, and each of them have their own benefits. But for brewing, kappa has got a higher concentration of alternating 3,6 anhydro-D-galactose and B-D-galactose desulfate units, so 4-sulfate units. And it's these, which help work pH, create a negatively charged molecule, and they remove positively charged work proteins. In hot conditions, the molecule, the polysaccharide, the carrageenan, favors a random structure, but when you chill it, it becomes helical and prevents gel formation. So not only does carrageenan clarify the wort at the front end, so the beer is easier to filter, it will clarify quicker in tank if that's how you're clarifying your beer, but also it can compact trub in the whirlpool. So if you look at the top right-hand side, you will see 2 whirlpool cones. One is a control with no carrageenan, and the other one has our product Compact CG, which is our carrageenan. And if you notice, the trub cone in the trial, the Compact CG, is much more compact. The control is more stratified. Due to the compaction of that trub cone, you are going to recover more wort, which will increase your extract, which will be able to ferment more wort. You will decrease your losses. Also, because the trub cone is compact, you are not going to take off lumps of the protein and lipid, and they will not go forward into the fermenter, which will impact negatively on flavour, clarity, and foam downstream. Regarding carrageenan, it's really important that you optimise. I do sound like a broken record with this, but with every malt change, malt supplier, malt variety, proteins are different, pHs are different. pHs really influence on carrageenan performance. If you have a low protein year, you do tend to use less. If you use too much carrageenan, you'll end up with higher sediment levels. So if you look at the optimization, I appreciate it's a dark beer, and for this instance, we'll pretend it's a dunkel. So as you can see here, towards the end, the higher addition rates, you do get a large fluffy sediment. And the clarity of the wort does not change. So you really need to be bringing that addition rate down to about 20 ppm, so ensuring you've got bright wort, but nice compact sediment. The easiest way to check this is if you take a sample of wort post-paraflow, have a look at it after about 15 minutes, you'll see some flocculation, have a look at it the next day. Ideally, you've got nice bright wort and a nice compact sediment. You really should be looking for under 5% sediment. As I said, if you do increase copper fining level, what you can find is that when you move over to fermentation vessel and you're taking the beer off the fermenter or off the CT, you'll find that the interface is quite loose, and therefore you may find that you have increased beer losses there. So you're really wanting to ensure that your interface is very discrete between your beer and your protein level in the fermenter. Again, this is just another slide showing how carrageenan actually works to an extent regarding particle size removal. So as you can see here on the blue line, you've got a wort that hasn't been treated with carrageenan, and the orange line is a wort that has been treated with carrageenan. And as you can see, there's a significant reduction in the particle size of proteins in the wort, especially at the lower end, where you'll find issues with clarity and issues with filterability. The chart here is really showing you that carrageenan works on all the different particle sizes. It's not just focusing on one area, it does reduce across the board. And then the evidence of really how carrageenan can impact on your filterability and on the clarity of your beer, especially if it's really important when you're looking at lager and you're wanting a nice, bright, crisp post-filtered product. The trial here had a haze of 54 EBC. The trial was 12. The control had a haze post-filter of 0.9 EBC, which is still pretty good for a post-filter beer. However, we brought it down 20% to a haze of 0.7. And really the most important thing, we are looking at over a 2-fold impact on the filterability of the beer, which, as Nate will mention, you really are increasing the filterableness of your beer. Moving on to fermentation, and he will cover anti-foam and nutrition. So yes, foam is desirable, but you want it in the right place. We're wanting it in the glass. We don't want it all over the fermenter floor. We have a silicon-based anti-foam, very low addition rates, very long shelf life, and it can be used in the kettle and the fermenter. It is heat stable. And what are the benefits by using an anti-foam for your lager brewing? Well, obviously, it will increase your tank capacity by up to 25%. But as you can see on the left-hand side, when you're not using an anti-foam, you're having a yeast head that is sticking to the side of that vessel. And in that yeast head, you're looking at alpha acids and you're looking at foam-positive proteins. They're lost. They're not in the beer. Especially alpha acids, especially when you're looking at a lager that's been brewed with novel hops, you really wanting to ensure, because those alpha acids are much lower than what you get with American hops, you're really wanting to ensure you're getting really good efficiency, good usage of the hops that you are using. And also with the alpha acids, they are really important for foam stability as well, because they increase the foam membrane strength. So you have the alpha acids obviously for the bitterness, you have them for the foam membrane strength, and then you also have the foam positive proteins that you're keeping in the beer to improve the foam potential of your beer. And then obviously it goes without saying regarding cleaning costs, effluent charges, and also if you're now looking at doing CO2 recovery, you'll have a cleaner CO2 as well. Moving on to nutrition. So historically, you would tend to have an all-malt fermentation. High protein malts, there wasn't really an issue regarding fermentability of the wort. But now we're looking at different beer styles. There are different beer styles coming through for lagers. So higher adjuncts, you can be looking at Mexican lagers, which have a higher level of rice. And then also you can be doing high gravity as well. And basically, if you are using high level of adjuncts, then you are reducing the amount of amino acids available to the yeast. And nitrogen levels have got, amino acids have got a marked effect on yeast growth, providing the form of nitrogen in polypeptides and amino acids. And again with FAN, again when you bring any beer, any lager, you need to be around 150 ppm for efficient fermentation. And if you are looking at those high gravity ales, those high gravity lagers, that does need to be higher, between 200 and 250. So you do need to ensure that the FAN that you're producing, that you're giving the yeast to utilize, is sufficient. And also making sure that the malt is of the correct quality as well, because if you are lacking in sulfur-containing amino acids, such as methionine and cysteine, if the yeast doesn't get enough from there, you'll start producing its own, and that's when you're starting to get some sulfur off flavors. Diacetyl reduction and nutrition. Obviously, some people like diacetyl in their pilsners. It's again completely up to whatever kind of style of beer you're producing. But usually, if you're using a well-balanced, if you have a well-balanced wort, using maybe some yeast nutrition, then you'll find that you'll be hitting those VDK rests and the diacetyl levels right first time. It really does improve. If you've got a healthy fermentation, you do find that all your flavor characteristics are much more in line with what you're wanting to achieve. Zinc. Zinc is obviously very important, and especially when you're lager brewing, you require more cells because you're fermenting at a lower temperature. So always ensure that you have a good level of zinc, and especially if you're propagating too. If you're propagating your own yeast, then you do need to increase your zinc by about fourfold than what you'd do for a standard fermentation. Just running through the benefits again of good yeast nutrition. You will get faster fermentation. Your yeast will be happier. It will reduce the off flavors that are produced. You can increase the adjunct usage, whether you're doing that for cost savings or whether you're doing that for the style of beer that you're producing. You can improve. You can increase the high ABVs and produce the higher strength lagers, and also you will be ensured that the yeast is happier and it will have a good viability over generations if you are repitching your yeast. Going on to nutrient types, there are various nutrient types you can use. There are very simple ones, such as a DAP or a zinc sulfate. Moving on to complex ones, such as the Life Extra that we have, which has got vitamins and minerals and nitrogen source, and then also some zinc as well. And then you can have your specific, which have got more bioavailable nutrients. So, for instance, the Saccharomyces is an enriched, zinc-enriched yeast, where the zinc is more bioavailable for the yeast. So you tend to get much better vitality and improved performance when you are repitching. And then, for instance, our yeast LIFO, if you're looking at really wanting to, if you're losing a high level of adjunct and you really want to bump up the nitrogen level, yeast LIFO is a specialized yeast autolysate, which will give the yeast the required amount of FAN and other amino acids just to ensure that your fermentation goes to plan and there aren't any off flavors produced. Moving on to maturation, clarification, and stabilization. So all those tanks, all those long, with the beer being stored cold for ages, you were looking here for diacetyl removal, sulfur off flavor removal, and also clarification. It's much easier now. We have ways of getting rid of sulfur. We have ways of getting rid of diacetyl, and also clarification. We can improve the clarification of the beer, even upstream by using carrageenan, but also downstream by using other clarification agents that I will come on to later on. But let's talk about diacetyl removal. So basically here, as I mentioned before, some lager producers do want diacetyl in their beer. However, if you don't, the general rule of thumb is that you will do a diacetyl rest, where you will increase the temperature of the fermentation at the end, towards the end, to about 16 degrees for 2 or 3 days, and this allows the yeast cell, which will have expelled the alpha-acetolactate when it was producing its valine, to change it into diacetyl and then bring the diacetyl back and then change it into flavourless acetoin. But that does take time. It takes energy to actually warm and cool an FV up. So basically, using an enzyme such as ALDC prevents the formation of diacetyl. What will happen is it just breaks it. If there's a direct break, if you see the red arrow, the alpha-acetolactic is completely changed straight to acetoin. It completely misses the diacetyl step. So you will not get that rancid, buttery flavour if that's not what's in the profile of your beer at all. So it completely protects the beer. You get your fermentations right first time, and you don't have to do a diacetyl step, which saves you time. It frees your vessels up, and it reduces your energy costs as well. Just moving on here to just to show you a trial information regarding LDC. You have a wort that was treated with LDC and one that wasn't. And as you can see, the blue line, the LDC treated wort, never really hits the flavour threshold, and there's no need for a diacetyl rest. So LDC completely eliminates the need for diacetyl rest. It reduces your energy costs, and it's really speeding up that maturation. Other off flavors are sulfur. So some people would always say lagers do require a little bit of sulfur. However, if you are continually getting sulfur in your beers, it could be due to stress yeast. So you could be looking at per malt or nutrition. So always have a conversation with us regarding your yeast nutrition. Your yeast could be a little bit sensitive to sulfur production or sulfur as well. So be careful with that. If you are getting sulfur in your beer and you really want to remove it, such as H2S or DMS or other sulfur off flavors, we have just launched a new product which is called ISYS Reduce. And in a similar vein to the Saccharomyces, it's basically a copper that has been bound to inactive yeast. So it requires a very, very short contact time. You would add it into maturation vessel where you would notice that you had the aromas, and then you can actually take it sediments down and it can be removed by clarification. And because that copper is bound to the inactive yeast, you do find that there isn't copper leakage, so there aren't any risks regarding the formation of copper forming the reactive oxygen species and forming oxidation and further off flavors downstream. And it's much quicker than, say, purging the tank or waiting for those sulfur off flavors to dissipate. Moving on to clarifiers. So as Nate will mention later on, what we're really trying to do regarding making that lager, and if you are filtering your lager, you really want to be bright, you are wanting to really take off the solids loading upstream. So you have your carrageenan upstream to take out some wet proteins, and then further on downstream, we can look at centrifugation to take away yeast. You can use silica sols, isinglass. Isinglass is a very traditional refining agent. It's made from the swim bladders of tropical fish. It is basically a collagen molecule where you have positive and negative charges, so it's incredibly effective at clarifying beer. Takes out protein, then takes out yeast. And there are other alternatives as well, such as we have a product called Protofine, which is a pectin product, which again clarifies the beer. Looking at the right-hand side, again, we've got a particle size curve here. The green line here is pre-centrifugation. So you've got your yeast peak and then your protein peak, and then you have your post-centrifugation, which is the orange line. So you've taken away your yeast, but that protein peak is still there. So this is something that you need to be aware of if you are looking at going into centrifugation, that you really need to make sure that your centrifuge is set up correctly, because if not, you can cause actually more problems and break down the particle size of the proteins, which will take longer to clarify out or cause problems on your filter. So it's always a really good idea to actually check that you have your centrifuge up and running. And then if you're centrifuging it and adding isinglass as well, as you can see in the blue line, that curve is completely, it's very, very low. That beer will be so easy to find, so easy to filter. Or some people just go ahead and just package it without filtering. But what are the benefits of using your clarifiers? So as you're presenting that filter, much brighter beer with a reduced solids loading, you don't have to use as much filter powder if you are using filter powder. You don't have to rebed your filter, and your increased throughput. If you kind of take your mind back to the carrageenan chart, and when we showed you the improvement on filterability by using carrageenan, if you're using, say, isinglass or say gasol or other alternatives, you will really improve the throughput of your filter, increasing your efficiency through the brewery. Moving on to stabilization. So we'll move on to chill haze formation in the next slide, but we need to really talk about what your shelf life requirements are for your product. Obviously, small pack requires a much longer shelf life than, say, if it's a draft product. So small pack products generally, if we're looking at lagers, if we're looking at wanting to keep that beer bright, will require more stabilization. And then we'll go through the options regarding PDPP, silica hydrogen enzymes. So basically, beer haze is generally caused by the interaction of polyphenols and proteins. And there are always other compounds to consider as well, such as residual starch and some beta-glucan. But generally, in a well-produced lager, the haze increase in shelf life will come from polyphenol and protein complexes. And when we're looking at maturation in the cellars back in the 15th century, that is kind of what was happening there. They were forcing that chill haze out and for it to precipitate out. So what we're looking at here is the first formation, which is chill haze. So the first step to colloidal or permanent haze is chill phase, and it's when covalent bonds are formed between the proteins and the polyphenols, which is this diagram here. Sorry, I didn't label it. It's a smaller molecule. The bonding is weaker. Therefore, when you warm the beer back up again, the haze disappears. As the polyphenols are polymerized, they get larger, they react with more proteins, the molecule becomes larger, and bonding is irreversible. And as the molecule gets larger as well, it is picked up by light scattering. Therefore, you see a haze. And this haze, because the bonds aren't broken, will not be it will not go away when you warm it up. It is a physical haze. So this is one of the issues regarding lagers and regarding shelf life in small pack. You do find that if your beer has not been stabilized, you will find that the beer will increase in haze through the life of its shelf life. The main issues here, obviously, are polyphenols from hops, but also hoarding in the barley is mainly responsible for the primary haze active proteins due to its high concentration of proline residues. So how can we get rid of polyphenols? We could use PDPP. So obviously, as you can see, it's a polymer which mimics proline, and therefore it binds very, very effectively to polyphenols. And it's used at really low rates, especially with lagers, because the hop loading does tend to be lower than, say, a hoppy beer. So for a delicate pilsner or a helles, a really kind of a low rate of 20 grams per hectolitre would pretty much suffice and makes it really quite an economical choice. There are various ways you can use PPPP. You can use one shot, you can use it in the copper, and you can use a maturation vessel where you just use it once. Or you can use regenerable PPPP. These are you can get impregnated sheets, or you can actually get stabilized PPPP units now, a bit like a crossflow filter. And unlike the use of silica hydrogel, the beer doesn't need to be chilled. You don't have to reduce your temperature there. Moving on to taking out the other component here, we're looking at taking out the protein, the prolines basically. So when you're using a silica hydrogel, you do need to chill your beer down to a lower temperatures for the proteins to come out of solution. But the good thing about silica hydrogels is that they do have a very controlled particle size. So when you are stabilizing your beer using a silica hydrogel or a zero gel, which is basically a silica hydrogel with the moisture reduced, so you don't have to use as much, you are only taking out those haze forming proteins. But like I said, you do need to chill your beer down to -1, and you do have to have a way of dosing it into the beer. But it is super effective at taking out haze positive proteins. Addition rates can be somewhere between like 50 or 60 if you're grams per hectolitre, depending on the kind of beer that you are producing. And then moving on to kind of the new generation of stabilization, this would be using enzymes such as clarizyme, very similar to alternative ones. You're cleaving out the sensitive proline, haze sensitive proline, which therefore reduces your chill haze formation. Also, because you're breaking that molecule down, you're reducing your gluten levels. Very simple to use, straight through into a fermentation vessel, very, very low rates. It's super efficient, and you don't have to, it doesn't require any chilling or any dosing. Moving on to oxidation and flavor stability. I think I need to speed up a little bit here, sorry. Flavor stability, the destabilization of flavor really does start to occur as soon as it's packaged. And then most flavor changes, you are looking at of flavors such as trans-2-toluene, which is a cardboard flavor. You get a lot of bitterness, and your ester character can reduce due to the degradation of amino acids and acetate esters. Exposure to high temperatures, light vibrations, and contact with oxygen and transitional metal ions will accelerate the beer aging. So if you're packaging your beer for export or traveling long distances, especially in warmer countries, your beer is really quite susceptible to oxidation and oxidative flavors. And the sterling precursors are developed upstream. So as I mentioned before, you really do need to have good oxidation control and good process control in the brew house to really minimize the concentration of the precursors. So for instance, lagering, don't do so many deep red rakes to really try and keep your filter cake kind of intact if you can. And maybe again, like I mentioned before, use tannic acid or an antioxidant to ensure that you're really scavenging the oxygen compounds there. And like I mentioned before, tannic acid as a blend will also chelate the metal ions, ensuring that the metal ions can't go forward and produce oxygen, reactive oxygen species. Going forward, looking at other areas where oxygen will cause issues in brewing, you'll be looking at packaging. Packaging is the next stage where you will find your beer quite vulnerable to oxidation. So here, obviously, keep as much oxygen control as you can in your brew house. But again, the use of antioxidants can help. You have got KMS, potassium bisulfite, so the sulfites, because these react with the oxygen, but also the oxidation precursors such as aldehydes, which will be oxidized further down as sterling compounds. And then ascorbic acid, and this prevents the breakdown of humulins, degradation of amino acids, and oxidation of fatty acids to aldehydes. So again, if you're using these two antioxidants in combination with each other, it provides a really secure package to ensure that you're preventing oxidation in pack and that your beer will taste as fresh 6-12 months down the line as what it did when it's packaged, and that you won't have colour pickup and you won't have haze. Okay. Other brewing resources. We have got loads of information that we can share with you. We have our Lager Made Easy, which goes through the entire process of lager brewing. We have a white paper again on yeast and yeast nutrition. And then we have a white paper on hydrogen sulfide and ways you can avoid that being produced in your beer. We have process aids documents as well. We have one on nutrition, and then we have one on an overview of process aids, and then we have a specialized one on enzymes. We also have documents on how to best do copper finding optimizations, how to optimize using isinglass, and how to optimize using Protocell. And like I said, if you do have any questions, please feel free to get in touch. We're now going to move on to filtration and Nate.
Okay. Thank you, Sarah. That was great. Appreciate all that information. Yeah, I just want to say at the outset that if you follow direction from Sarah, filtration downstream right before packaging is going to go much, much easier. If you don't, then it's going to be a tough day in the cellar, but a lot of important information, and you definitely can't view filtration as a standalone process. It's definitely part of an overall program. So we'll talk briefly about goals of filtration. So very simply, we're looking for clarity and stability of final product. Those are the two things we want to sort out, and we want to make sure that those happen consistently and without issue or delays. For lager filtration, or any filtration really, but talking about lager today, some common issues that we see in filtration is that it's hard to get through filtration media. We use too many sheets, mods, carts, or whatever your media is that you're using. Another issue is filtrate quality isn't consistent. Our filters don't work. Filtration takes way too long. It's not realistic for our packaging timelines. or there are quality issues, high DO pickups or contamination during the filtration process. So some fixes for some of these common issues. Oftentimes we see that they might not have the right filters, might not be using the right media. They might not have the right size filters. What worked last year for you may not work this year based on the growth of your brewery. And you might not have the right steps in the filtration setup. And when we talk about filtration setup, you can view that as simply as getting the filter prepared for a day of filtration, or filtration setup in what happened upstream in manufacturing and processing, and how did you prepare the beer for filtration. I'm going to talk through this presentation in a few different sections. One is filtration process equipment selection, what you might see in breweries, what you may already have, what you may be looking to purchase. And then we'll talk media selection, what's the appropriate media for that specific equipment. And then we'll also talk about some recommendations and best practices. So jumping into filter types and how they work, this is kind of an overview of what is available to brewers. Not necessarily comprehensive, but these are some of the common filter systems that we see in facilities. Bag filters, or sock filters, sometimes called, centrifuge, sheet filtration, lenticular filtration, DE, diatomaceous earth, or pressure leaf filters, sometimes cartridge filters, and crossflow. And these are all applicable in breweries. They may not be your final filter to achieve the bright beer, the polished beer that you're looking for, but there could be a combination of multiple filtration steps involved to achieve your goals. So some of the considerations for equipment selection are the power consumption. What kind of utilities are we using for this filter? What are the product loss ramifications? How much is there product loss associated with specific filtration? The capital cost to purchase this equipment is certainly more intense for some systems than others. The media cost, the consumable cost of day-to-day filtration, the labor that is involved in running these filters, and then the disposal of media as well is important to consider. So I'm going to go through some of these fairly quickly because these are not necessarily going to get you to your bright beer finish, but definitely worth mentioning as options, part of the plan. So bag filters and centrifuges. I consider these both good options for bulk solids removal. If you've got heavy solids that you're trying to remove from your product prior to final filtration, these both do a lot of heavy lifting. But they're not going to get you your bright beer that you might be looking for. This is what I'll spend the bulk of the time talking about, specifically sheet filters and lenticular filters, and also diatomaceous earth filters, which I won't talk too much about. But this is considered depth filtration. This is where you can really run these filters and select media to achieve your end goal. And this is probably what you're going to see most commonly in small to medium-sized breweries for producing bright beer. And then some other equipment that you may see: cartridge filtration. Cartridge filters are, they're different than lenticular modules. The construction is different. If you have one of these housings, you can use this for 20 different things in the brewery. You can use it as a membrane filter, a final filtration, sterile filtration. You can use them for very small depth media for bulk filtration on much smaller batches of less than, say, 400 liters. And then also sometimes we'll see cross-flow filtration. This is not as common in breweries. It's becoming more common, but there are several companies that are producing cross-flow systems for breweries. These slides, because this presentation is recorded, and the assumption is that you can go back and look at these and do some comparisons, I'm going to kind of move through these quickly. But as we talked about before, bag filters and centrifuges, pros is good bulk solids removal. Cons is maybe not final filtration. Depth cartridges, if you're using cartridges as your final filter, they're good because they're versatile. You can get into them pretty easily. Downside is very limited dirt holding capacity. You'll outgrow them quite quickly, probably. Now with depth filtration, with DE filters, again, we see these in use. The people that are continue to use them love them. We don't sell a lot of them anymore, but they're certainly applicable in breweries. But what we see more often is the sheet filter and the lenticular filter. So I'll talk a little bit about those a little more in depth here in a moment. So filter media selection, this is critical. You've got your filtration set up, you've selected your filtration equipment. Now, how do you select the correct media for it? Because you have a lot of choices. We'll talk specifically about depth filtration as it relates to sheet filtration and lenticulars. These look a lot different. You've probably all used plate filters before. Maybe you have or have used lenticular filters. The media is the same media, right? It's just in different formats. And so sheet filters, this is a very old technology. It's been around for well over 100 years. It works really well. If you have a plate filter and it works for you, that's great. This media is still available. Let's say you use a Sites K250 sheet for your filtration. You can get a Sites K250 lenticular module. So it's the same media, just in a different format with some hugely different process decisions. So which we'll jump into here. So depth filtration, really important to understand that with the correct media selection, you are achieving several different things during filtration with depth media. You're what most people think of as filtration. You're holding out particulate that is stuck on the surface of the filter. You are also, because it's a matrix and that sheet may look flat, but it's quite intricate. But you're trapping particulate in the maze of the filter as well. And then with certain media selection, which is really important for lager and pilsner production, specifically is adsorption. So you want to select media that has a filter aid embedded in it, so that we're getting adsorption as well as particulate removal just based on size, because the media is charged at that point and it's attracting other particulate that we're trying to remove. Apologies that there's a lot of info on this chart here. Hopefully you can zoom in and take a look at it. But when it comes to, say, the Sites K-Series media or some of their more common media, selection is really important. Some of these, the Permadur down to the K300, great for solids removal. You may expect some haze. Now here's where we get for lager production in the bright beer selection. K250 and below, that media is going to contain DE, and that's going to really help to polish a beer. K300 and above, no DE. So you're still doing solids removal, but you're not achieving that adsorption that's really going to help you get to a bright beer. And then you get down into some of these grades, and you're not only achieving bright beer, but you are potentially doing some micro reduction based on your goals. So we'll talk now this section, process aids for better filtration. This is, and as I mentioned at the outset, really important to do the work upstream to make filtration go much better. Because if you are relying on your filtration for removal of all things that could cause clarity issues in your beer, you're going to have a really tough go of it. There's a lot of work that can be done upstream with process aids to increase your efficiency and your quality, for sure. You're going to decrease your filter usage. You're asking much less of your filter when you're using process aids upstream. So you're going to get easier filtration and more throughput. You're going to extend your filter life. In the case of lenticular filtration, as opposed to sheet filtration, typically it's a one-time use. Lenticular filter, you can use these over and over. You can get maybe up to 10 generations or regenerations out of them. The less often that you have to regenerate your filter, the better for that filter and the better for the filter life. So you're going to get more throughput through these filters with the use of process aids upstream. And then obviously freeing up labor. If your employees are not spending time tearing filters apart and regenerating and back flushing and messing around with filters, you're obviously going to get faster and more efficient filtration. So talking about what we're trying to remove from product. We're looking for clarity and stability, and we want it consistently and without issues or delays, and that's where colloids can cause us trouble. So colloids, Sarah already talked quite a bit about it, but in beer, we're looking to remove protein and polyphenols. These are partially soluble particles, and they can come from a number of sources, from raw materials, the grain, from microorganisms, whether we pitched those microorganisms or they showed up uninvited. Important things to remove from beer. And so when we talk about colloidal stability, colloids are partially soluble, but they can form insoluble complexes, creating hazes and things. And they can also attach to other things in the beer that we want to leave in the beer. They can strip filtration through some of these complex colloidal removal. So we're looking for stable colloids that don't cause visual issues. They have no filtration issues. The unstable ones are the ones that we want to be aware of and handle correctly. So those are the ones that are responsible for hazes and precipitates and all kinds of filtration issues. This slide, I'm sorry, it's a bit dramatic, hopefully not too jarring for everyone, but this is not a beer, but this is an example of when colloids can cause big trouble. This is an RTD product where there was a late addition of an ingredient that took an otherwise stable beverage and made it completely unstable. So we've got big trouble at filtration. So if any changes are made to the product, whether it's raw material inputs, a pH change, an alcohol change, a temperature change, you can have a fairly stable beverage that becomes quite unstable. So it's very important to prepare the product prior to filtration. And some of the best practices and recommendations, obviously using the process aids like Sarah had talked about, using them at the correct dose rate, contact time, and temperature, very critical. Some of these products, carrageenan and beta-glucanase, silica sol, and isinglass. Cold stabilization is very important, -1 to 0 C for 1 to 2 weeks, and then very important to filter cold. If you filter at a different temperature than you cold stabilized, you are likely going to have trouble. Using the right filter media for clarity, as I mentioned, making sure that you're using media that has a filtration aid in it to remove all that particulate and those colloids to produce a bright, stable beer. And then when it comes to microstability, we didn't talk too much about that, but you definitely want to consider whether you're using sterile filtration or pasteurization for microstability in packaged product. Thank you.
Okay, thank you, Nate. Thank you, Sarah. I'm bringing you guys all back to the main view now. Okay, well, let's answer a few questions. Lots of great information there. A few follow-up questions now. First question I'll give to Sarah. Sarah, are these enzymes available in homebrew portions?
Unfortunately, no. The smallest size that we do will be 1 kilo.
Okay.
Sorry.
Next question.
Enzymes available for home brewing, though, if you go on the internet. Sorry.
Next question for Sarah. Sarah, can you discuss the products that we have for adjunct conversion in lagers, and what are their parameters and performance and under typical mash conditions?
So usually when you're looking at mash conversion for adjuncts for lagers, you're really looking at AMGs, you're looking you're looking at alpha amylases, and then you can also bring in a fungal alpha amylase as well, which is more of a multigenic enzyme. So it all depends on what you're actually wanting to achieve. So generally, when you are looking at trying to get that terminal gravity, you do actually need to use really quite high levels of enzymes in the mash to ensure that. So you can be looking at upwards of something like 10 kilos per metric ton of grist to really try to achieve good conversion into glucose if you are looking at really improving or increasing your attenuation in lager brewing. It's not kind of like cut and dried. So, for instance, it generally it's probably better actually to get in contact with us if you're actually wanting to actually achieve something specific for your brewing. Looking at an alpha amylase, for instance, these are the ones that you would use in cereal cooking, especially high temperature ones, because they will really help convert. They will work much better at the higher temperatures that you require for gelatinization if you are using whole grains rather than using torrefied or extruded. And then obviously when you're looking at like a fungal alpha amylase, if you use a fungal alpha amylase at the same time as using an AMG, you really do get a good synergy between the two enzymes, but you have to be careful regarding temperatures. So an AMG, for instance, can go up to say 75, 80 degrees centigrade, whereas if you're using say a fungal alpha amylase, that does top out about 65. So if you are looking at complete conversion, then in a combination of those enzymes, you really need to keep your mashing temperatures on a little bit on the low side to ensure you're getting complete conversion.
Okay, thanks, Sarah. Let's see, one more for Sarah. Can you comment on the difference between Clarazyme and Clarex?
They're very similar. Obviously, since the patent has been lifted on Clarex, there are a lot of people producing a specific endoprep days. So it works in a very, very similar way to Clarex. You would use it in fermentation. You would use it at the start of fermentation. Again, if you're using high adjunct wort, then the rates can be lower, such as like about 1 ml per hectoliter. Whereas if you're using all malt or say high amounts of wheat or oats, then you would need to be up between 2 and 3 ml per hectoliter kind of rate. But so very, very similar, but achieving the same output.
Okay, thanks, Sarah. A few questions about filtration for Nate now. Nate, can you comment on the aroma loss in depth filtration versus cold setting?
Yeah, I can. I feel like this might be one part me, one part Sarah here, as opposed to or depth filtration. If the product has not been prepared properly for filtration, there can be some compounds tied up in some of those colloidal matrices that are going to be removed through filtration. I don't have any data on that in front of me, but that is certainly a consideration and an argument for preparing product upstream. I don't know, Sarah, is there any data loss as far as cold settling and some using some of these products? I'm sorry, not data loss, but aroma loss during cold settling. I don't have any data on that.
No, neither do I actually. Generally, we're looking at here. I'm assuming the conversation is between like traditional maturation, like -1, where you're getting the polyphenols and the proteins combating together and then precipitating out. So you probably would get a little bit of aroma loss if you are looking at a very high solids loading being presented to that filter, because you tend in that respect to tighten the filter bed up, and therefore you'll be removing other compounds as well. If that helps.
Okay, thank you. Do you have any, Nate, another filtration question. Do you have some advice about improving performance for lenticular filtration?
Yeah, setup and obviously media selection is a huge part of it. We have on our website, on Scott Lab's website, which maybe we can post that after the fact, or a link to the specific article. We have several articles on lenticular filtration operation, whether it comes to from setup, operation, or media storage between filtrations. So the best practices article is a wealth of knowledge for running and operating a lenticular filter as best as it can be. So perhaps Eric, maybe we can link that at the end, or if I know who sent it, I can send it directly to them. But we have a lot of filtration best practice articles on our website.
Excellent, thank you. Do you have Nate? Do you have any ideas for improving cartridge filter performance in general?
Yeah, so cartridge filtration is a great tool, as I mentioned. It can be used for a lot of different ways. If we're talking about using a cartridge filter as a final membrane, what you do upstream and the time at which you've done that upstream is very important. So if you filter a beer and allow it to then, if you filter it, everything goes well through lenticular, the beer is good and stable, and then you allow that beer to sit and potentially change over the course of a week or so, you can that colloidal matrix can change, and then all of a sudden at cartridge filtration you're going to have quite a bit of trouble. So if you're using it as a final membrane, your preparation leading up to that point, very, very important. If you're using it as a depth filter, which it's kind of hard to talk about that almost because there's such little surface area on it compared to a sheet filter or a lenticular filter. If you're using it as depth filtration, obviously the media selection is important, but then your batch size is critical. We really see about 100 gallons as being the sort of upper limit of a batch using a cartridge filtration for as depth media.
Okay, thank you. I have a question about cartridge filtration runs. What is the average number of runs you can get out of a cartridge filter? What is typical, and maybe extend that to how far could you push that if you follow best practices?
Yeah, this is, I guess I'm assuming that we're talking about lenticular modules here. This is a little tricky, and I'm terrified that it's going to be recorded and available forever. But I've seen it really. It depends on how you treat your filter and what you're asking of your filter. And as I mentioned, how many different regenerations can you do? Regenerations can be hard on a filter, and that usually results in the end of life. It's not necessarily about how many solids you threw at it; it's how many times did you have to regenerate it. So we give some guidelines of, 8 8 regenerations is probably typical. But really, I've got some people in the coffee space who are using lenticular filtration and they're getting like 15 generations out of it, which is kind of unheard of. The most important thing is you're checking your pre-filter quality and your post-filter quality, and if you continue to get the throughput and the filtrate quality that you're looking for, you can continue to push it. But usually end of life would be, we're getting a very much smaller volume through a filter before we have to regenerate, and then it becomes a time issue. So yeah, I would target 8, but be ready to go up or down depending on what you're asking of your filter.
All right, thank you. Question about lenticular filter. Is it better to push with CO2 or with a pump?
Whatever you can do consistently. So CO2 is great. Pump is great. Diaphragm pump, not great. So whatever we can apply a very stable pressure at. And really for normal filtration with lenticular, we want to target, normal running at, 7 to 10 PSI, somewhere in there. I wouldn't go over 14 PSI if you're looking to regenerate that filter. Go up to that ceiling, then the stop, you regenerate. Maybe if it's your last filtration, you can go up to about 30 PSI. But I wouldn't go to 30 PSI on a normal production if you're planning to regenerate. That's a lot to ask for the filter. But gas or pump, either works as long as the pressure is consistent.
Okay, thank you. A follow-up question, also with a cartridge filter. Same question, CO2 or pump, is there a difference?
Same.
Okay.
Same answer. Consistent pressure, monitoring your differential pressure across the filter is the most critical, and whether it's supplied with head pressure on a tank with gas or a pump.
Okay, thank you.
There
are. We're at our time, but there's one more question I'm going to give to Sarah before we sign off. Sarah, what do you think is the most revolutionary enzyme to date, or I guess in general, which enzyme types do you find are kind of revolutionizing the brewing industry right now?
Oh, I think with the move over from classical enzymes to genetically modified organisms, I think we're actually going to see some really interesting products coming out of the market related to brewing. There's a couple of really very, very boring, but I think beta-glucanase is superb. It's not revolutionary, but boy, does it do a good job in your brew house. If you've got a stuck mash, it really does help. But revolutionary, I think Clarix is actually quite a good one. It's really out of the box thinking of a different way of actually being able to stabilize your wort, your beer, sorry. And also, it kind of, if you take it to its extreme, you can just really take away any cold conditioning time. You can literally ferment, centrifuge, chill it before it hits a filter, and then straight on. It theoretically, in practice, does revolutionize how quickly you can turn around beer and lager. But I think coming to the future, I think there's going to be some really interesting products coming onto the market for brewing.
Okay, thank you, Sarah. Thank you, Nate. I think we're going to leave it there. Thank you, everybody, for attending the webinar. And again, the webinar was recorded and will be available through the original Crowdcast link, as well as on our YouTube page eventually. Thank you again. Have a great day.
Yeah.
Bye.
Thank you.
Bye.